2.6 repeater and 1.3 repeater are the third and fourth terms of an arithmetic sequence. So we have term 1, 2, 3, 4. So this is 2.6 repeater and 1.3 repeater. This basically means 2 and 2/3, and this means 1 and 1/3. 2 times 3 is 6, plus 2 is 8, so we have 8/3. And 1 times 3 is 3, 3 plus 1 is 4, and we have 4/3 as an improper fraction. Let's find the common difference. We're going down. So what is the bigger number minus the lesser number? 4 minus 8 is -4, and the denominator remains the same. This here is our common difference, D. So we're talking about term 1, term 2, term 3, and term 4. Term 3 is 8/3. And each time we go to the right, we go down by 4/3. So if we go to the left, we're actually going to, instead of subtracting 4/3, we're going to add 4/3. So we'll take this term 3 number and we'll add 2 times 4/3 to get the original term 1. So what's 8/3 plus 2 times 4 is 8/3, and the answer is 16/3. This happens to be our term 1, the first term. Let's try to derive the arithmetic series formula. This is an enrichment challenge. We write out the sum of a series with A representing T1, the first term, and the second term we're going to add a common difference D. It increases by D. The next term, term 3, increases by another D, or 2D, and we keep on increasing 1D at a time until we reach the end where we have A plus n minus 1D. If you recall, this is also Tn, the Tn formula. Let's write out this list backwards. So starting from the end and going to the beginning, same sequence backwards. Now we're going to add these two series vertically. Sn plus n, Sn is 2Sn, the equal sign remains, and A plus A is 2A. And we're going to add in a diagonal pattern where we're going to add in this manner here. A plus n minus 1D is, square bracket, 2A plus n minus 1D. And we continue this diagonal pattern where we have A plus A. And when we add a D here, the n minus 2D becomes the n minus 1D. So again, we have the same result. And this pattern keeps on repeating right to the end. The last summation would be A, this bottom number here, plus this top result here. A plus A again is 2A, and we have n minus 1D. So we're repeating these square brackets quite often. How many times? We're repeating them n times. So this result is repeated n times, or we're going to multiply by n here. Finally, we divide both sides by 2, resulting in our arithmetic series formula. Now, why are the following formulas equivalent? This here is your Sn formula, as well as this formula here, the one we just derived. A happens to be T1. Why are they the same? It's because we substitute this expression here for Tn. Tn equals T1 plus n minus 1D. It's one formula. And we replace this with this part here. And so T1 plus this expression here, T1, becomes 2T1. And this part gets copied over here. Let's find the sum of the first 100 terms of this arithmetic sequence. So we have plus 3, and this is a series because we're adding all the numbers. Sn is equals to n over 2, 2t1 plus n minus 1 d. This here is the formula that adds up all the numbers. Now we know what n is. It's 100. So the sum of the first 100 numbers is 100 over 2. 2 times the first term, which is 2, plus n minus 1d, n happens to be 100, and the common difference d is 3. A 100 divided by 2 is 50. 2 times 2 is 4. And we have 100 minus 1 is 99 times 3. And this happens to be 297 plus 4 becomes 301. So what's 301 times 50? And the answer is 15,050.